empowering your real life with Raspberry Pi. I've made the code and slides public. I won't show much of the code in this presentation, but it's available on GitHub for everyone interested. It's all quite simple. So even those unfamiliar with Python should find it easy to use. Let's get started. The presentation tells the story of a Python engineer who has not studied electronics and thought, I want to try hardware, but it seems difficult. I don't know where to start. Through trial and error, he developed products and began to think. So interesting and fun. It can enrich real life. Now, let me ask you: how many of you have no hardware experience? No. Okay, thank you. I hope my talk has inspired you to use hardware to enrich your life. First, let me introduce myself before starting this story. I'm Shintaro Matsudo, a software engineer from Japan. Working at a startup company called Levcom. Let me give a brief introduction about my company. Levcom is on a mission to reinvent communication and offers a product called Meter. We offered Meter reinvent various forms of audio communication, such as phone calls, web meetings, and face-to-face conversations, meetings. And we provide not only in Japan and also Indonesia. Recently, we have begun offering a service named Scan to Call. QR codes are transformed various fields, such as payments. Scan to Call eliminates the need to manually enter phone numbers. Like this, you can make a call just by scanning this QR code. Of course, it's completely free. I set up this call to be answered by a text-to-speech system and AI IVR system. So you can get the information you need without human interaction. If you'd like, please give it a try. No one tried. Just kidding, thank you. Let me continue with a bit more about myself. I love these things. First, my kids, and outdoor sports, such as trail running and long hiking, like that. Tomorrow, I'm running a full marathon in Japan. But now, I'm really into electronics. And as you may have noticed, I'm the person in this story. Chapter 1, Encounter with Raspberry Pi. I have always wanted to try electronics, but never know how to start. Then I had a one-on-one meeting with my colleague, and we talked about electronics. It seems difficult. I probably need to study electrical engineering. I need soldering tools. I don't even know what is necessary, another things. And my colleague said, don't worry, I have a Raspberry Pi lying around my house. I'll give it to you. Then a few days later, a Raspberry Pi 4 Model B starter kit arrived at my house. Let's take a look inside. The kit includes a Raspberry Pi board itself and micro HDMI cable and a case and a power cable and micro SD card. The micro SD card comes with the OS pre-installed. These 6 items are necessary. In addition to the starter kit, I prepared a display and keyboard and a mouse. Finally, I had the Raspberry Pi. My first lesson, first of all, get the starter kit. It's important to dive into without thinking too deeply before trying anything. Chapter 2, hardware is still difficult. I assembled the starter kit, and it was very straightforward, very easy. It's time to start. Now switch on. Uh-oh. It doesn't start at all. I don't know how to debug hardware. Without no logs, no metrics. I had to eliminate possibility one by one. I spent about a week, a week without a solution. Finally, I suspected the micro SD card that came with the starter kit. I bought a new micro SD card and prepared new OS. Preparing OS was very simple. I just downloaded Raspberry Pi imager from the Raspberry Pi website and wrote the OS to the micro SD card by my computer. After inserting the new micro SD card, I powered it on again. Now, this time, it booted up. There was no waiting time, and immediately saw this screen. After completing the various settings, I finally stood at the starting line. As a side note, I used UV for the Python environment. It's very useful. My second lesson, hardware can fail. With my environment ready, I started thinking about what to create. Since I often forgot my schedule and I work for a voice communication company, I decided to create a secretary that could answer questions like, what's my next schedule, or what do I have scheduled today? So I named it voice catering. This is the overall concept. Input from the microphone, and speech exchange the voice to text, and if it's a schedule-related question, check Google Calendar and convert the text into natural language using generative AI, then exchange the next text into voice and output from the speaker. This is the library I used. You can find the actual code on GitHub if you're interested. Oh, ここからでちょっと。
Accident remote configuration market.
Okay. A little small, but it's okay. Yeah, but I managed to create it, this schedule bot And I realized, do I need to do this with a Raspberry Pi? I can do it on a regular computer, right? So my third lesson, hardware starts when get creative with input and output. The road to becoming a hardware engineer still seems long. Chapter 3, encounter with sensors and Pycon. So what should I create? How about using sensors to collect data? That's it. I use GPS sensors and an accelerometer to track movements. I name it Track Tracker. Since I love running and hiking and almost moving, this seems like a great idea. But at this point, I realized I didn't know that what tools or knowledge I needed. So in such cases, there's only one place to go. I decided to go to, this is Tokyo. I decided to go to Akihabara. Do you know Akihabara? No? Yes, yes. Akihabara is famous for its electronics shops, many electronics shops, and recognized as the center of Japan's otaku and kawaii culture. Because of electronics mecca, I've always wanted to visit. I went to the top two electronic component stores, Akizuki Denshi and Sengoku Densho. At first, I was very nervous, so trying to hide that I was a beginner while Googling what I need. Like, so, but there were so many parts. So gradually, I started exciting. So it was very interesting and fun. So it was supposed to take 1 hour or 1 hour half, but it took 3 hours. It was very fun. I got a Raspberry Pi Pico. A Raspberry Pi Pico is a very small, low-cost microcontroller. Different from the Raspberry Pi 4 Model B, what it can Pico can do is almost limited to electronics. There is no operating system, no OS, and it can be programmed in C or C++ or MicroPython. I also purchased a display, screen, and buttons, sensors, and jumper wires, registers, LEDs, and breadboard. Breadboard is tool that allow to build circuits without soldering. I realized and I needed to calculate resistance value to buy registers. It's been more 20 years since I last encountered registers and Ohm's law. I thought it's Nausicaa of Ghibli animation. Do you know Ghibli? Ghibli is not so famous. Okay, thank you. Anyway, this time I bought registers that have large enough resistance value. Lesson 4, soldering tools and electronics knowledge aren't necessary at first. Chapter 4, the final chapter, hardware is. What will hardware mean to me? Will it still be difficult? Or is it starting to get interesting? Now, emergency occurred. My daughter nearly had to be hospitalized due to a cold. She and my son, younger daughter, younger brother, had been hospitalized before for the same cause. The cold prevented from breathing properly and reduced their oxygen levels, dropped to dangerous levels. So I wanted to create something helpful for them. So I decided to change my project. I decided to create a pulse oximeter. This medical device can easily measure blood oxygen solution and pulse rate. It measures the amount of oxygen in the body, and by shining light, a sensor placed on a finger or earlobe, I named it O2 Keeper. I decided to build it in 3 steps. First, blink LED. Blink LED is the hello word in a microcontroller. Next is display something on a screen. Finally, O2 Keeper. Let's start with blink LED. The necessary items are jumper wires, registers, and LEDs, and the breadboard. Next, let's talk about the development language. As I mentioned earlier, we can use MicroPython. Of course, I use MicroPython. MicroPython is a lightweight version of Python 3 designed to run on microcontrollers and small embedded systems with limited resources. It allows developers to use Python code to control hardwares such as sensors and LEDs, and supports common communication protocols like I2C and SPI. It combines Python's ease of use with efficient performance on low power devices. The logo on the right is the older version. The left is the newer version. I was able to develop easily thanks to MicroPython. Very easy. Next, let's try blinking LED using MicroPython. Here's the code for blinking LED. The pin class imported from the machine modules. And this class is used to control the GPIO pins. GPIO stands for General Purpose Input and Output. And its operation is controlled by the user at runtime. I set the pin 16 to output mode. This is a pin-out diagram. It shows information about each pin. Pin 16 is located in the bottom right corner. And the ground, this is ground, is the return path for the electric current. When current flows from GPIO 16 through the LED and back to ground, then the LED lights up. And the code runs in an infinite loop using while true. And I wrote this code using Sony. I can't pronounce well Sony well. Many Japanese struggle with the th sound. Anyway, it's Sony. Sony is the default development environment for the Raspberry Pi. So I developed Pico using Raspberry Pi. After running the code, the LED blinked successfully. You can see that current flows from pin 16 through the LED and back to return to ground. And now next, display something. I prepared this OLED display model SSD13Y5. This SPI communication protocol requires more wires but offers faster data transfer than I2C protocol, which will be explained later. And then worked successfully. Hello Python APAC 2024. This component has 5 minutes. This component has a library making it easy to draw text and shapes on the screen. It's a good idea to check if such libraries are available before purchasing a component. Finally, AutoKeeper. Let's create the AutoKeeper. This sensor is MAX30102. I decided to use this sensor. And no, this is AutoKeeper. When I touched the sensor, display the auto level, now like 91%, 92.5%, like this. I really, finally the AutoKeeper is complete. I really enjoy organizing wiring neatly. This device can help keep my kids healthy. I bring it today, so if anyone is interested, feel free to try it on. So it was so interesting and fun, and I feel hardware can enrich their life. So for me, hardware is kawaii. I began to find Raspberry Pi Pico very lovely and cute with its very small size and endless possibilities. I still have many things I want to do and need to do. Basic of electronics, soldering, robotics, data logging. Yeah, I'm really looking forward to it. Terima kasih. Thank you. This.
Okay, thank you, Mr. Sintar Matsudo, for such an informative presentation. Okay, the last thank you again for in here, and we hope you found the conference insightful and inspiring. And we thank you to everyone who participated today. Have a good day, and please wait for another session after this. Okay, give applause to Mr.
Thank you. I was looking for Akihabara style distinct in Indonesia, but I can't find it. So if anyone has any information, please let me know.
It's not here in Jakarta. If you want to find the reference,
Really?
in Jakarta.
In Jakarta?
Yeah.
Yeah, I was in Jakarta. Yes. And if you interested the code size, this is
Training going to be going to deep dive into MicroPython after this. Okay. If you want to go deep into this MicroPython, do you know Shell?
shell. Ah, yeah.
Since you use Shell,
Uh.
have you used it?
No.
Right now you can. Yeah, you can try this one on MicroPython. I've given MicroPython workshop actually yesterday. Yesterday I give MicroPython workshop with this.
Oh, really?
Yes.
Uh,
So you can try this one. It's already runs MicroPython. But
Thank you. Where the workshop?
already yesterday, Friday. In here also.
This Pycon APAC.
As well. So yeah, you can try this one if you want to go deeper with MicroPython. But it can also run Arduino. But what I know, generally, I like to use M5 stack. You know M5 stack?
Yeah.
Yeah. There are many projects with M5 stack.
Thank you.
Not many are using the shell, so maybe you can try the shell. It's basically ESP32. ESP32 SV.
You said what? Pico is cute. This is cuter.
Yeah.
Smaller.
Yeah.
So shell is
The sensor?
no. It's bigger.
Camera.
Yeah, you can make a MicroPython camera project based.
Oh, I'll try.
Yeah, webcam. Like it can also do a small detection, but you can use it with Arduino.
Thank you.
Yeah, like person detection. I forgot to introduce myself.
What is it used for?
This is Wi-Fi antenna.
Uh,
Because it's so small, you cannot put the Wi-Fi antenna on the PCB. So you have to put an extra